This is Stefan, mostly talking about the weather, so a very, very English topic. Stefan, all yours, buddy.
Thank you very much. Excuse at the beginning because it's a very big topic. There's a lot to talk, and I'm just skipping over. I hope I have provided a lot of links in the presentation, which you can later use if you want to go a bit more deeper in any topic. I have also a colleague, Suvi, with me today. If you later want to have some question or discuss with us anything, we're here to stay shortly after the meeting to discuss something. So let's get started quickly about me. I'm the head of the developing section at ECMWF, which I will explain in a second. I call myself veteran software developer because I'm quite long in the business. I've done graphics when SGI was still doing graphics. And now getting more and more to use the open source environment and things. But as you can see from my names, I'm not very creative when it comes to come up with my names for the GitHub and Twitter. More importantly, we have a developing section of over 20 developers now at ECMWF, C++, Python, a lot of web developments, databases, of course, storing data. There's a lot of developments going on for us. There's a lot about software packages we provide, not just for ourselves, but for the community around the world, the meteorological community. So it's a very big job for us to do. There's often a lot of different formats, and time criticality for weather is very important. So that's a big driver for our developments. But I mentioned ECMWF. What is it? ECMWF stands for European Centre for Medium Range Weather Forecast. Very short, brief name. We are an intergovernmental organization, so even though we have Europe in the name, we're like the European Space Agency. We are intergovernmental, so we're not part of the European Union. We do a lot of work with the European Union, as you will see from my presentation, but we're not actually part of it. So we're not directly affected at the moment by things going on, let's say this way, indirectly. But we have 22 member states about Europe, 12 cooperative states. And if you look at the map, you realize there are some countries which are member states which are not in the European Union, so we're a bit wider than that. We are mainly located headquarter-wise in Reading, UK. We're starting since December, months ago, we started building a new data center in Bologna, Italy. That is where in future our supercomputer will go, but the headquarter will stay in Reading, west of London here. We are now roughly 350 staff located all in Reading at the moment. So what we do is mainly is a 24/7 operational aspect of weather forecasting. That means delivering the forecast time critically to all our users, customers, which are mostly national weather services, but also weather business agencies, businesses. This means in practice terabytes of data being delivered very quickly within minutes around the world. We are operating to do that HPC, a supercomputer center with 2 supercomputers, which, as I mentioned, we will move to Bologna in 2020. And we're also operating the biggest archive on meteorological data with 250 petabytes at ECMWF. So you might guess now what we're doing from the name Europe. I explained weather forecast, but you might wonder what is medium range. And medium range, many mistake for being the distance, but it's actually time. And it's defined as 3 to 15 days in meteorology. Perhaps to explain why we're doing it and why it's so special for us is you go back to the 60s when the first idea came to create the center. In the 60s and beginning 70s, weather forecasting progressed to do forecasts beyond 2 days. But if you want to do any forecast beyond 3 days, as you can see from the weather system, which is there on Florida, and within 4 days, it hits the UK. So if you want to do a forecast in 4 days for the UK, you need to know what's happening in the US. So to do anything, you need a global forecast. And global forecasts are highly expensive to run. You need a supercomputer infrastructure. It's a lot of data involved, data moving, and it would be very expensive if every weather service would do it around the world. So in the 60s, the member states, as shown before, came together saying, let's put this effort together because a global forecast will be for everybody the same. And that is exactly what the center does. We provide this forecast beyond 3 days. So if you see anywhere around the world a forecast beyond 3 days, it's very likely that the forecasters will have looked at our forecast. So that is something which, there are other medium range forecasts, but forecasters around the world always take different models into account. And we are definitely one of the that we'll look at. So what does ECMWF provide at its core? As I said, operational forecast. I mentioned the medium range. But this medium range, as I said, in the 70s, we started to look 3-4 days. Now we're actually already running monthly and seasonal forecasting. And as you can imagine, when you go in these kind of time ranges, the forecast, there will be lots of uncertainty. So what we do actually, we don't run one model, we're running 52 models. We run one in high resolution, one with the best starting conditions, and then 50 forecasts, which in a lower resolution get slightly tempered, slightly changed starting condition. And that will give us statistically information about the credibility of the forecast. So if you would run one single forecast, you will run lately after a week, the uncertainty of that will quite go down. But looking at the spread of forecast, and here you can see it's plotted on the right side, the 52 different forecasts, you can get information which you then can use statistically to analyze the certainty of a forecast. And then you have products like on the left side, which give them the uncertainty, and you can see the bars of uncertainty over the time. So in very simple terms, and that is very much simplified, how our system works is you get lots and lots of millions, tens of millions of observations in, which have to be, of course, data quality needs to be done, they must be validated. All these observations then get fed into the model, which we call the integrated forecast system, which analyzes the data, does a good starting condition for the model, and then runs the model, which has different components, which I don't go in here at the moment in this talk, but different things, and then produce the model output, which we then, what we call here the product generation, is a time-critical delivery to all our users. And there's also web services, because there's also forecasters want to look at past forecasts, want to study more in detail other parameters of the forecast that they can do through the web services. So that's a chance. And as I mentioned already, we are operating a very large archive. Data coming in, model output is all stored there in the model. To do it all, we run supercomputers. As I said, we run 2 supercomputers, one research, one operations, and it gives us also a fallback. In case something happened to the operation machine, we can kick off the research work and use that machine for operations. Quick word about what comes in. As I said, it's tens of millions of observations coming in, mainly nowadays is satellite data. And it might look like satellite is now what is driving. It definitely improves the quality of the forecast, but the other observations are very important as a reference also to calibrate satellite. So that is still important to keep in. Oh, and why we're generating this plot is because we have also a monitoring function. We're giving feedback to satellite providers, to the different agencies who collect the weather information to say something is possibly going wrong or the data is biased. So that means we have a lot of statistical analysis and graphical analysis of what we are getting in as information to give feedback on that. A word about the model output we're generating. It's all, most of the layers of the model actually are spherical harmonics representation, something you will not want to use in day-to-day work. On them we have also something called Gaussian grids on which model are worked on. And this is needs very carefully consideration when you look at output, because if you look, you might be familiar with satellite data where you have pixels for which a value is for an area, but for a model it's about grid points. So the value you get from the model is only valid at this grid point. If you want to have any make any assumption or any analysis about any point between grid points, you need to interpolate. You cannot just do a simple assumption that this point is the nearest time. So that's very important differences to what you would see with satellite. But very few users work with these raw data. They normally get it already interpolated by us. It's part of this product generation software we run, that we also in real time generate it in grids, how users use it. And then even then, users that do mostly 2 things, either do the products I show here on the left, where they do take the, as I said, these 52 forecasts, do statistical analysis. This, for example, is a map popular with forecasters. It shows anomalies. So where will it be colder than usual? Where will it be hotter? Where will it be more wet than usual, more dry, more windy? So that gives some guidance to see which in the next 2 weeks possibly there will be changes to the weather and where they then will keep an eye on. And then on the other side, let's see, on the right side is another important way how users look at our data. They settle for a location. I think it's Reading here. And then they will have a time series of the data of the 15 days or 10 days, depending how long they want to look at. And then they see how the parameters they're looking at will develop over time. And as you can see in the middle one quite nicely, the uncertainty over time is increasing. So that is what you expect with a weather forecast. It would be weird if it would be, but it gives weather situation where actually the certainty can be better in the second week than in some days of the first day. It can happen. Quick thing about the data I mentioned already, we're preparing ourselves at the moment for a big increase of data, a factor 5 at least coming in, because we know there's a lot of more satellite data coming in, and also our way getting more data in. We are better now to analyze data coming in and allow more data in, because we're now much better in accepting data if there's some uncertainty with them, because our algorithm take part of it. So that is definitely increasing. But the big increase comes factor 1,000 in decrease of models. The center, it's not long ago that the grids were 100 kilometers, and we're now talking about less than 5 kilometers grid on global scale. And that is showing then in the data amounts we will have. But I mean, this is purely what I said about the weather forecast we're doing in the medium range, these kind of data. But ECMWF, and it's normal for weather forecasting, there's a lot of other activities which follow up from weather forecast. Weather forecast is often the beginning of a chain to use other products. And we have a big cooperation with the European Commission. You might have heard about the European Copernicus program. It's a massive big program by the European Commission to make Earth science and Earth observations data much more easily available for private citizens, but also industry. And we are part of that one. It's 6 services that are mentioned above: atmosphere, marine, land, climate change, security, emergency. On behalf of the Commission, we're operating the atmosphere and the climate change. And we're very heavily involved in emergency, because flood forecasting and fire forecasting, we do a lot. Forest fire forecasting, we do a lot at ECMWF. So we are heavily involved in this one. So we play a big part of this one. It's sponsored by the European Commission. Just to mention, the atmospheric monitoring service is very interesting if you want to build or want to look at data like air pollution, chemicals in the atmosphere, sand and dust, which in some areas have a big impact on, for example, flight routing and things like that. So, and there's an example here, the column of sulfur dioxide in the atmosphere. So it's very interesting to check on quality, air pollution and quality. All the data from the CAMS is free and accessible for anybody to build products on. And the Commission is very keen of users using this. So there's a lot of activity. So if you're interested in that, go to the data, to the link I put there to the data of the service. Then the other service I mentioned is the climate change service. This is mainly reanalysis data, the seasonal forecast I mentioned, and also climate scenarios, which not so many are done at ECMWF, but we connect them to the service. And the CDS, the Climate Data Store, is the way how it's presented. It's a portal on its own. And it's very interesting why I'm mentioning it here is because a lot of these data sets are too large. The reanalysis data set, which is very, very popular for a lot of industries, because it contains the weather of the last decades. So it's a record of the last decades of weather, very interesting for industry. A lot of products are built on top of it. But the data set I think, is now going beyond 5 petabytes. So it's not something you just download and work on. So what actually the data, it offers data download, but what it also offers is actually an interface which allows you to access the data through Python on the server side. And it's all started last year. So if you want to have a go at it, we're really looking for feedback. But this is really a new step for us to let users on our site do products. And what you do is, that's perhaps a better shot, you're writing your Python script, so you have seen with the decorators, I hope you see better than I can from here. You define with decorators your interface, which parameters you want the users to choose, and then you generate a graph, or you can generate a product, but a graphical one is the easier. So here I plot for the last 8 years the 2-meter temperature, so the ground temperature at London. So you can see the seasonal variation and also the variation over the day, making the line very thick. So you can do apps, you can develop little applications on this portal. And the next step will be to have a little app store where you then can share these kind of apps and make them available. But at the moment you can see you have the code and you have your own area where you can do your own little scripts and stuff. So if you're interested in any of these data sets, this is something you can play with without having much to invest on your site. So now I'm starting a little bit more talking about the Python, what we use it for at ECMWF. We build a lot of systems. We have a service for forecasters which around the world can look at our forecast. So they don't need to get all the data. They can look, often they cannot even get all the data because it's not physically not possible. So this web browser is called EC Charts, allows them to see this data. And this is a web interface where they can interactively go, select different parameters, look at hurricane developments. I don't go into detail this one here because we presented actually a colleague of us 3 years ago. He presented that here. But another thing we do is I talked about downloading data, which you can go by going to the web page, select a data set, and then click it out. But you can also do it through batch, which you might want to do because otherwise you get a strain on your fingers clicking all the data you want. And we allow it through Python, a Python interface we have. And there's information for the ECMWF data, how to get, and the Copernicus data. You can install these APIs through PyPy. I only put the links here because there's information how you can set it up because you need an access token. You have to accept the license condition, which is free, but you have still to accept that before you can have access. Another thing we use Python is we have massive big suites. Suites are defining the workflow we have at ECMWF. Data coming in, as soon data is processed, feed it into the model, have the model, the different parts of the model running, then do the post-processing, archiving the data. All this has to be expressed, and it has to be done, of course, in a way that it has dependencies. As soon this job finishes, start the other job. Make sure that operators, we are 24/7, so we have always staff working around the clock. They can immediately see if something gets delayed. So we have a workflow manager called EC Flow. And this is the user interface you can see on the right side, how an operator, an analyst, a forecaster, a researcher can see how their jobs are doing. But to define these suites, we use Python. We have defined a Python interface for users to define how the jobs are, what has to run, and how it gets scheduled between the different machines. Because some workflows start on a supercomputer and then go on processing machines. So it also goes beyond across machines. So that shows a bit we build system, we organize our work with Python. So what's about the number crunching? And for a long time, we have a lot of number to crunch. We're time critical, so we have to do it. Also on the HPC, but for a long time we did not look at Python. We traditionally use a lot of Fortran. We're still in the model, mostly Fortran. We have now for post-processing and most services moved C, C++. But we have now started looking more and more in Python, and I definitely would say that the environment under Python definitely has improved of what we have seen in recent years. So we're very happy with that. I think you will find there's a lot of NumFOCUS logos which we're making use of. We use it a lot now for the post-processing validation verification of the forecast. But the real challenge is for us, what I have not talked about, and I don't want to talk about is we have quite a lot of different formats which are not publicly used formats. They're very specific to metrology, very optimized for what we're doing. And to get them all in these standard tools, that is not very easy. And that is often the challenge to make use of. We see there's a good tool, but how do we get our data? And that's a very big challenge. And also for users, we don't want users having to understand how our data is organized, because that is not the main problem. They want to extract data, they want to subset data and get the data they want. So we're trying to abstract it in Data Cube, so that users have a way to access the data without learning something very specific to metrology. And what we found very interesting, what we started using since 2 years now, is X-array, which is, you can say, a more multidimensional pandas. And it has really proven to be very good for us, especially for the user side, how to more easily access our data. But this structure is very much oriented to NetCDF, a format used in metrology, but not much in operation metrology. So what we did, and I think that was a big step for us, we went to the community. We had 2 Python workshops where we invited key people from these packages to ECMWF, discussed with them how we can improve this situation, because there's really a lot of good developments out there which we want to make use of. It's only that we need to make it also easy to get our data in. We learned a lot about, especially, we call now our new Python interfaces more the second generation Python interfaces. The first generation we started off with 15 years ago. They were just the same Fortran and C interfaces. We just transferred them into Python. So your Python program looked like your Fortran program, just Python syntax. So you don't really gain much out of it. You just can say you do it in Python. And worst case, you got it often slower than also because you did not make use of anything from Python. So that was an important lesson also to go out to the community and really learn what we're doing. And one thing we're really interesting is developing things like Dask, the distributed processing of data. And we were lucky that we had actually very good session at our last workshop at ECMWF last year, that we could have a good session about it. We had very good talks and discussions, because it was a real workshop. We also should get back to we not just sit and listen like here, we had also a round table and had how we can proceed and how we can do it for our community. And there were other weather services too, it was not just us. So we're really interested to look at that, and that's something we're now exploring, how we can do much more distributed processing with Dask on our data. Just a nice short URL in the bottom if you want to have a look. We recorded all the presentations, so if you want to have a see what we've done, please follow the link. I hope there will be a PDF where you then can click on the links on the Okay, I said now how we get our data in. So there is X-array, a very nice package. It's done by the community, and how we can make use of it. So we're very proud that we did the right thing of talking to the community, and we actually managed, we have a format called GRIP, which it's very specific to metrology, not much known outside metrology. And we work together with the community and a company called POpen in Italy, how we could implement it. And now X-array with an extension can now read the GRIP data directly in. And that means as a user, you only would work with X-array. And if you have X-array used before, you don't need to learn anything new to work with our data, because you can use what you have done before. The only thing is, if you say when you load the I'm going here to. If you load the GRIP file, you say engine CF GRIP, and then it knows that it has to go and get the CF GRIP and loads and then reads it. So it's hopefully for the users the easiest way to work with it, and after that it's a data array. Okay, I got a sign that my time is running out. Just to mention, historically for 30 years we have also provided a graphics package to do weather maps. It's very data aware from the meteorological point of view, so the users has a very high level package to do visualization maps. It's also now Pythonic and can be used within Jupyter notebooks. But what I would like to say is all these different packages we have, the decoders, the visualization, the interpolation I did not mention, but they're all coming together in what we call METView. METView is our workstation batch system we have at ECMWF. It had its own macro language, which was already very, very close to Python. It was only close, it had not the module import and everything, but the syntax was very similar. So what we did now is we actually made it Python, so you can actually also write the batch script in Jupyter notebooks, and it's very helpful for all our users who use our workstation, because what they actually do is, as analysts, to do quickly generate batch jobs, they're actually generating, so they're setting up their plots, setting colors, and then what they do is they open, let's say, an empty Python script, and they drag and drop this icon in, and it generates the code for them. So whatever they have defined, where the 2-meter information comes from, they don't need to worry how the code is, they just drag and drop and generating this code. And then they can just say visualize, and then they can see the data. And then we have now transferred all to Python, so that is, can be used from Python. Very quick word, we are, that is new for us. A year ago, that would have been an empty slide. We're now getting out GitHub, PyPy, Conda. We have a Docker Hub image. We really try to be there. And as I said, we also try to have tools which users can easily use. So how you can say, I mentioned already Docker Hub. We have a Docker Hub image. If you want to play with our software around, have a look at that. It's install our software, all the Python interfaces, and there is also lots of Jupyter notebooks which you can see what we are doing and how you could work with our data. Yes. Quickly, yes, that is definitely the important slide. I also pitch a little bit here now for us. We have job offerings at the moment, but also in general. I think quite interesting one. As I said, we're pushing quite the limit of data and systems. We're very much high performance computing, web developments. We're really having very interesting tasks. So if you're interested in that, have a look at our webpage. What we're also outsourcing and tendering out a lot of our developing work. So if you have a little company or you're a consultant, you might want to have a look at this page. We're looking generally for help and can look for contractors or, for example, in specific areas like porting IDL code into Python. It seems to be something quite a lot of people do because we realize we're not the first one doing it. And otherwise, as I said, we're now getting to GitHub. I mean, we are also wanting, we had already always contribution with other weather services stuff regarding our software. Now we want to put it out and really more visible, like the CF grip I mentioned. This is all out, and please have a look if you want to contribute to our open source software, because we're definitely open for that. And last but not least, we're also doing a summer of weather code. We started that last year. So we will, unfortunately, slightly too early because we have not published yet. On the 21st of January, we will publish our challenges. So we at ECMW have looked around what kind of challenges talk to our users, what were little tasks which we not managed to do, and where we can need help of the community. And then we will select, you can apply for if you think you can do something, write a little proposal, and then we select 5 proposals for over the summer with a little bit of pocket money, work on these problems. And there will be some Pythonic one, there will be one, definitely about one visualization one. I have to mention that. So have a look at that and see if that might be of interest for you. And that is all I had to say for. Thanks.